Okay. We're back for part 6. Let me share my screen. Okay. I don't know what problems I want to do today. Man. Let me do. I'm going to go through, do a few problems as a warm up. I'm live streaming. No. Yeah, so for this problem, find a subarray with the largest sum and return its sum. Like, I have this low-key memorized. But I think let's see. It's a larger sum 6. Yeah, I mean, essentially, what we want to do let's do for I in range of length nums. We want to have like a max variable. And then a sum variable. Yeah, because we're going to take the sum. I kind of want to do it this way, though. Let me try and not use the max. Plus equals sum plus n. Actually, let's just do the max function, because it would essentially would just do sum equals sum plus n, and then we'd make an if statement if sum is greater or less than n. Then we just set sum equal to like the index at that value. But I could also just do this. My second time doing it. Third, my fourth time. All right. Yeah, I think I understand how to do that. Let's do 21. Should I just do design Twitter? Let's just do it. Let's do test that scheduler actually. It's my fifth time doing it. This is a heap. Let's go here. Let's go to all the problems I'm doing right now are just essentially to warm up. Delete all this. Yeah, so I know three. You have to wait two, so it has to be boom, 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 boom. Okay, yeah. So I know for this question, minus n for n in counter task dot values. Right, because essentially what we want to do is we want to get the and I do remember this like problem. I've done it multiple times, so that's why I'm not really going through and reading the question multiple times, just because I've done this so much. But I do know that essentially we have to have like this number of like placeholders after each letter, right? And the best way to do that is to use a max heap. You're going to use the max heap. You're going to pop the elements from the max heap. You're going to add them to a queue along with like a time value, and you're going to decrement like the count, the count of each distinct letter as you add it to the queue. And then basically you're going to pop from the queue when your time variable is equal to whatever time you stored it in. It's easier to, I feel like this problem is just easier to explain when I actually do it. So yeah, I'm gonna heapify heap, and then we're gonna need queue, and we need like time. Yeah, so now we're going to check like if heap or if queue. Okay, I think it's if heap, right? Because we need to pop it off. Right, and we're going to add that. We're going to add this q dot append n, right? And we want to check if q and q of 0, 1. Oh, we also have to decrement it, right? Q, I think this should be my +1. And I think if this damn, this question is going to be the end of me, bro. I just need to think through it, because if q dot append, if the heap, we need to decrement the first element, like the value that we pop for the heap from the heap. And so do we need like another if statement if no, I don't think we do. If the heap, this one, I think this should be fine. And if this is equal to time, heap push this. And I think we're just returning time. Pretty sure that this makes sense. No, I did something wrong. I think if heap or queue, if heap if P plus no, because while it's a heap, right? While it's not empty, we're going to heap pop from the heap. And we're going to add 1, right? Because we want to pop it from the heap, and we want to increment by 1, right? Increment the count, because incrementing it is the same thing as decrementing, like in a max. Since the values are going to be negative, you want to add 1 to the count. When do we want to add 1 to the count? When we're popping it from there, yeah. So I feel like this should work. If heap or I feel like I'm missing a if statement somewhere where I should be checking if the value that I'm popping is greater than, is less than 0. That's what I should be doing. Let's see. Pop equals heap pop heap. If pop is less than 0, then we're going to am I gonna do? Q dot append Q dot append heap. I mean pop +1 time plus n. Okay, this should work, I think. Okay, no, it doesn't. Yeah, okay, well, it looks like I'm gonna have to do this tomorrow. What did I do? It's gonna add the one. Oh my god. So I know, like, I'm doing this. Why didn't this work? What I was doing working? I was not working. What was I doing wrong? Could I have done this? Wow. Oh, that's crazy, man. It's like I'm there. I'm almost there. Like I understand the logic. I just keep making dumb mistakes. I've done this problem 5 times. I've done it like every day, and I always get stuck. So I'm gonna do this again tomorrow. I don't have any notes. Let's do design Twitter. These are supposed to be warm-ups, and they're still kicking my ass. How many times have I done this? This is my 4th time. Boom, boom, boom. Let me reset problem. So I remember, like, with this question, what we want to really look at, like this method and this method are very simple, right? Because this method creates a new Twitter ID or tweet with ID, tweet ID by the user ID. Each calls the function. Is it retrieves the 10 most recent tweet IDs in the user's newsfeed. This is the majority of like the question. That's like this method right here is the hardest part. The user ID with you. So I know for here we're gonna do something like self. I'm gonna have like a dictionary. Followers at like follower ID going to equal follow dot add, right? Right. Self, and this one you're just gonna I use discard only because it won't bring up an error if when you remove it from the dictionary. when you remove that actual element from the dictionary. Discard. So we're gonna have self dot followers equals default dict, and then we're gonna have it be a set, right? And then we're gonna have self dot tweets is going to equal list. And we're also gonna need a count to keep track of like, we're gonna need like a time to keep track of like when each tweet is added. I don't even know, what is the runtime for this? Because adding and removing from the set is order 1. Remove, yeah, so this is order 1. So it's really just the get newsfeed. Posting the tweet, I'm pretty sure it's just order 1 because you're appending to the list in the dictionary. So get newsfeed is really where the majority of like the runtime is gonna come to play. We're going to be, I think a heap, worst case is nlog n. And then, so it's gonna be nlog n for each time we like get a newsfeed. But even then, we're only taking the 10 most. Let's say k log n, where k is like the number of like times you call get newsfeed. Anyway, so when we post a tweet, basically what we're going to be doing is we're going to be adding for this user, we're going to be appending it. ID. We're going to be appending it to the end of like the list that we initialized in this dictionary. And then we're going to need to decrement. I think, no. Time. Let's do that. So now what we're going to want to do because what are we going to do? We're going to add self dot follower. Oh, because, okay, hold on. We're going to want to go through our dictionary, and then for each user in our dictionary, we want to get all of their tweets, right? For like the follower and followees. But I think we also have to add, yeah, okay. No, we have to add our own user, because we also want like our own users like tweets and everything. Add user ID. And then we want to go through for user in self.followers user ID for posts in self.tweets at user. Yeah. Res.append. So we're going to append. What do we need to have? We need to have the post. Yeah, I guess we're going to need to append post or the time self. All right, now post. What am I talking about? Now we want the most recent. Yeah, so it says, okay, we have to decrement this. And then what do we have to do? I think oh no, we have to heapify it. I almost forgot to do that. Heapify res. And then well res actually let's name this heap. This is gonna confuse me. Heap. We'll append all this to the heap. Heapify heap. And we're gonna res equals this. Well, heap. And equals 0. We are going to res.append heap pop heap. Right, and we're gonna need what, the second element, and then we gotta increase n plus equal 1. Okay, and then we're returning res. I think this should work. Ah. Am I doing this in the opposite way? I thinking about this wrong? Am I thinking about this wrong? What? What? No, this definitely should be -1. Self.time. So it looks like I am doing them in the wrong order, which is telling me that I probably doing the heap, like doing a min heap instead of a max heap. Because we want the 10 most recent tweets. Oh, okay, minus equal. Oh, shoot, wait. No, yeah. Well, res. What is going on? File heap pop. Give me 1 second. Just got denied from another company. It's rough out here, man. All right. I'm about to delete TikTok. I re-downloaded it this morning, but I'm going back to deleting it. Let me see what's wrong. It's a small. I think it's definitely a small error. Like, I know this is gonna increase the runtime like crazy for no reason, but let me just see what I did wrong though. Bro, what am I doing wrong? Okay, I'm gonna have to go over this. Oh my gosh. I have to add that in the post tweet. I'm adding it in. That makes sense. Man. Man. Like, bro. I swear this is so embarrassing. I've done this problem so many times and I still mess it up. Like, this is embarrassing. I only looked at the solution because I'm really trying to treat these as a warm up, and I have to get on to the next question. Oh, whoops. These are all problems I did yesterday too. Like, let me just delete that. I remember with this question, so you are given an integer array, nums. You are initially positioned at the array's first index, and each element in the array represents your maximum. So like if you're here, you can jump a maximum of 2 times, right? So we could go 1, and then since we already got to 3, you could do 1, 2, 3, and then get to 4. If you're at 2, you could also do 1, 2, but you'll have 1 and then 1. You know what I mean? Here, you have 3 times. 1, 2, 3. You get to 0. You can't jump anymore. You could also jump to 2, right? 1, 2. You can't jump anymore. So we have to return true if you can reach the last index or false otherwise. This question, I know like typically, I remember like the solution is basically to start at the last index and then determine if you can jump, if you can get to here from like this index, if that makes sense. And then if you can, then you move like the pointer that you'll have here down 1, and then you do the same thing. So like, I know you'll need like a goal. This is gonna equal like the last index of the array. So you're gonna have nums minus 1. Should be while I swear sometimes I don't know if I should use like a while loop because we want to do this while the goalpost is what? Or should I just use a for loop for... Okay, yeah, I think we need to just use a for loop because we want to iterate just basically going backwards. For I in range length, we're going to start at the last index of the array, go to -1, and then we'll just go backwards. Okay. And then basically we want to check if if the index plus nums of I, right, if that is greater than or equal to goal, then goal is going to equal that index, right? We're going to move the goal down because we're starting at the right. Like, boom. So if we go through all of that, if we can, like if goals should be at index 0. If we go through all this and it's at index 0, that means that we can return true. If it's not at index 0, then that means we can just return false. So we can just return like goal equal to 0. Oh, whoops. And I don't know. I swear, like a part of me feels like I'm just memorizing solutions, but I also think that like I do get this. You know what I mean? Like, okay, this makes sense to me. Would I have been able to come up with it by myself? No. But I can definitely I understand the solution now that I know it. I guess we'll see. I'm gonna try and take some time between doing like I've been doing this problem, like these two problems every day for the past 4 days. And I keep getting them slightly wrong. I might try and take a bit of time in between doing them just to make sure that it's okay, I actually understand the problem and the solution. Yeah. So jump game, get that. Jump game 2. Do I even remember what is this question? Don't look. Okay. I remember this question. Oh man. Because basically what we want to do, so you're given a 0 indexed array of integers, nums of length n. Maximum length of a forward jump. In other words, if you are at nums I, you can jump to any nums I plus j. Return the minimum number of jumps. And I remember the solution for this is basically you have to reach index 2. There's the last index is 2, jump from 1. Index 0 to 1. Then 3 steps to the last index. Yeah, so I remember this question. You kind of have to think about it as BFS. essentially we're doing like a Dollar Tree version of BFS, because we're going to be looking at, we're going to have 2 pointers. We're going to start them both here. And we're going to look at what, like, where can we get to with the leftmost pointer? Where can we get to, like, with the rightmost pointer, right? And then we know, like, for the left pointer, this is always going to be equal to the right plus 1. And then we want to look at, like, all the children at the, like, the maximum amount of children between, like, the left and right pointers. So here, you know that 1, 2, 3, we can get to here. So each time we, like, do that whole process of updating the pointers, we're going to have, like, levels. You know what I mean? Like, boom, these 2, 1, 2, and then it's like boom here. So we know that it's going to take like 2 steps. It's going to have to return like the levels. I'm going to go. I'll be right back. Can you use the bathroom? Dad. Dad.
Yeah.
I got the sandwich.
Sandwich. I have one of this one. Right.
All right, man, we back. Goddamn. Yeah, so right. I want to do this well. We're gonna have and we want to iterate between for I and range. Right? All right. I'm gonna check. Go to one. I think farthest. You actually have to reset that after each iteration. After each iteration. I think we're all count. And then we're gonna have to increment the count. Plus 1 plus equal 1. I think this is how we do it. The flow Inabachi. Oh, guess not. Zero for I in range. I was going to equal right plus 1. I think this might have to be this. Oh, what am I talking about? I'm doing this completely wrong because it should be nums I plus nums I. Okay, yeah, there we go. Because I was forgetting like the actual value at the index. Like, I mean, the index plus the actual value at the index. That makes sense. That makes sense. Look at that, man. Thinking through it. Thinking through it, bro. Making improvements little by little. Let me check. See if anyone's watching. We have no viewers yet. I already know that there's going to be a point where I have like 20 viewers, maybe 7, maybe 6, you know? It's just about taking life one step at a time. That's all you can do. Just try and get better every day. I should be a motivational speaker, honestly. Yeah, bro, I just got denied from this company. Got the email. I think I got denied from another company. I had an interview on Thursday last week, just behavioral. And it's for like a research assistant position. That's not even like a crazy like engineering role. And yeah, the title was AI Research Assistant 2. And the lady, she was like, okay, cool. Like after the interview, she was like, oh, this is cool. This is cool. Well, like let me know like if you don't hear back by Monday, just please like email me, reach out, and like we could talk about the next steps. I felt like the interview went well, but you never really know. I emailed her last night and she just hasn't emailed me back. So I think I don't think I got it, to be honest. Not that I was like, they weren't really gonna pay that well, so I wasn't really like losing sleep over it, but it's one of those things where you just want to see something go your way. But it is what it is, man. I just did jump game. Okay, I did jump game. Three. And I just did jump game 2. Made it off ways. This ain't no Arachis. I'm so bad at debugging my code in Leetcode. I wish we had access to the debugger. But you need Leetcode Premium for that. And I realize I can just use print statements and stuff. But when I'm under pressure, I feel like I just can't. I feel like I can't think straight. If someone's watching me debug, I feel like, oh man, it's the worst feeling ever. I feel like they're judging me so hard because they probably will see the error, and it might take me like 5 minutes to even see what's wrong. Gas station. This problem I find so confusing based on the description. Like the problem itself isn't too complicated, but I think the way that they're phrasing the question is so bad. Because you have the gas. Amount of gas. Index I. Then you have the cost. Cost this much to go to the other one. So you could think about it as just subtracting.
That's what I was trying to do. As a matter of fact, 2 weeks ago I got a message that I had a secure message. And for the life of me, I could not find my credentials to sign it. And I'm like, oh, so I called up yesterday to try and, I don't know, something happened, we got disconnected and the resident that never called me back.
The way that I did this, right?
Yeah,
you can really do this problem by think about it as just like you have to. So you have the amount of gas at each like I stop. Then you have the cost at index I to travel to the next index. You can just think about this as like subtracting cost from gas, and then you'll basically get like the difference. And the difference, you can think about it as like, all right, we just the difference for between these two arrays will be let's see, gas. So it's gonna be -2, 2 minus 4, -2, 3 minus 5, -2, 4 minus 1 is 3, 5 minus 2 is 3, right? So this array right here, we're just gonna need to basically have enough like positive numbers to make it all the way around. So 3, you'll go to here, you'll have 6, right? And then you go here, 5, 4, 3, 2, or is it 3, 5? Because you use 1, 4, 3, 2, 1. Yeah, so you'll be able to just make it back all the way around. Basically, do like a cycle. And you can really just think about it like that, rather than getting confused in all the details of like gas and then cost. Just like take the difference, and then you can basically use Caden's algorithm, because if we like if an index is if the value at a specific index is less than 0, we're not even going to want to start here. So you can just like, this is negative, just going to start your count of like the, yeah, because you have to return the starting, like the index that you start at. So you're gonna leave this at 0. You're gonna leave this at 0, this at 0, and then you're gonna start here. That's the way they could do it. So, how am I going to do? Yeah, so for what I did, you don't even have to do it this way. You technically don't have to make a list.
Yeah.
Let's do like
July 20.
n is equal to length of gas.
Okay.
We'll have diff equal to
Yeah. Right. Okay. And so, yeah,
for
so
I
then those guys
in
need to know
diff
about 45.
for I in range
Excellent. I see. Thanks, God.
length of diff. We could just do n, right? Doesn't matter. They're all the same length. Actually, let's just do length of diff. So you can do diff at index I is going to equal gas at I minus the cost. And I'm using a bit more memory. Like I'm using n units of memory that we don't even really have to use. You can make this more efficient by just not even making this list. But for me, I don't know. I just like to do it this way. In an interview, I would do it this way. And then if they asked like, oh, how could we use less memory? I would just do this operation in the for loop, like the second for loop. So we're gonna need a like to occur some 0, right? And then basically we're gonna go through for I in range length of diff, right? And basically we're gonna add plus equal that equals cur some plus right? And then if cur sum is less than 0, we're gonna need a start variable. I'm gonna set cur sum equal to 0, start plus equal 1. No, actually, I think start is going to equal I. And we're going to return start. Oh, yeah, we have to check. We also have to check if there's difference. So if the sum of diff is less than 0, return false, or return -1, right? I'd do it differently. All right, roulette. Let's see. Gas station. Second time I've done this. Hand of straights. Do I even remember how to? Oh, I think I remember how to do this. Okay. Let's do this question. Alice has some number of cards and she wants to rearrange the cards into groups so that each group is of group size, and consists of group size consecutive cards. Given an integer array hand, where hand of I is the value written on the ith card, and an integer group size. Return true if she can rearrange the cards, or false otherwise. Let's look at the example. So we want a group size of 3. But true, Alice can rearrange. Alice's hand can be rearranged as 1, 2, 3, 2, 3, 4, 6, 7, 8. 1, 2, 1, 2, 3, 2, 3, 4, and then 6, 7, 8. Okay. I know that one of the cases we're gonna have to look at is if length of length of hand mod group size is not equal to 0. Return false. It basically means like if this isn't at a length that we can like divide into 3 into whatever group size is, we just automatically should return false. And then we also need to look at what else do we need to look at? So I think the best way to do this problem, you basically have to create a dictionary. I always name my dictionaries lookup dic. I might just do lookup equals count. We use the counter for hand. Right. Now, you can do this problem using a heap, but I just do it. I just sort it, honestly. I think it makes the solution easier. So we're going to need to sort it because we need the minimum number. Yeah, because we need the minimum number each time. So let's sort hand equals sorted hand. And then, so I'm going to go through for I in hand, right? If and then yeah, so we want to do for I range. We can do for I in hand. I don't think we actually get for I in hand. And then we can look up for J in group size. Because we want to check first if like the value of I, if that is 0, actually, I might leave this for later, but let's get to the meat of the problem. The meat. Basically, I'm gonna go through our dictionary and let's say for 1, 2, 3. So I'm gonna check if this element. Yeah, so we're gonna check if this element's in the dictionary, this element's in the dictionary for whatever the range is. So we're gonna do 1, 2, 3. Boom, 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 right? And we're gonna check if they're in the dictionary. And if they are, we're just gonna decrement them by 1. So it's gonna be lookup of I plus J. Well, I guess lookup of I plus J. Well, let's check. If J not in lookup, and just continue. If I plus J lookup I plus J less than or equal to 0, lookup delete lookup I plus J. Okay. Then So that just basically means that it's in it. And it's not the value at I plus j is in the dictionary, and it's greater than 0. Should I just return false here? If look up I not in, if I9 look up, should we just return false? I think we have to return false because if I isn't in lookup, yeah, that wouldn't even make sense. Okay. I think I did this problem wrong. But if we get through all of that, we should return true. Am I? Okay, yeah, okay. You see, I think I did this wrong. Yeah. Into objects. Oh, for I. Damn. Oh, what? I did it. I'm him. Let's see if it gets accepted. Oh, damn, I don't think it gets it. Oh! Ah, damn. Yeah, there's something wrong. I'm gonna look up my solution. So I'm him. I am him. I'm him. Stop playing. They're completely different. What the heck? Bro, look how many times I tried to do this. Okay. Did I just copy and paste the solution in? Might have. I think I definitely did. I don't write this many comments. Oh, so if there's no more, then I guess. Okay, that makes sense. I was thinking about it wrong. Because basically if this is not in lookup, we should just return false. Because that means we can't even format groups. Let me do this. I think this. See, for this one, I get how to do this problem. The logic makes sense to me. What the heck? I just forget. I think I'm just forgetting about certain cases. And turn false. So he doesn't even check if it's not in it. So he doesn't even care about that situation. He's saying if it's bruh. Told him I'm him, stop playing. Told him I'm him. Dang, Marcus Rashford isn't starting for England. That's crazy. I mean, is it crazy? Who's starting? Who's starting over him? Grealish plays on the left, right? James Madison on the left. I think he's on the right. Man, that's wild. Let's see. Now that I did all my warm-ups, let's go to. I feel like doing this. These are too many warm-ups to do because I feel like my brain's kind of fried. This one I should do again. I'm going to need to. I can finish all the rest of the medium problems today, though, and then move on. What am I going to move on to? I think I'm going to move on to backtracking, graphs. Maybe I think I might review trees, actually. I'll probably go to trees. I'll go back, review trees, tries, backtracking, and then graphs. Bro, graphs, man. And it sucks because I do not want to do, I don't want to do DP, bro. I really don't. I really don't want to do DP, but I probably will. How many questions? Oh my God. I think it's necessary. I think I just, I should at least spend a bit of time, even if it's not the main thing I'm focusing on. I just want to have a solid foundation in all the other topics before going into like more obscure topics that I don't know. Do companies ask DP like that? Like 2D dynamic programming? Man. Bit manipulation, bro. It's madness. Insert interval. I don't even know what this is. Maybe I probably will. I don't even think I'm gonna do any of the hards. I might do some of them. Like I might go back and do merge case sorted lists. I don't know. All right, let's do some more greedy problems. I think one of the big things that's keeping me going is just seeing like the level continue to go up. I like seeing the number of problems I do continue to go up. I was literally at like 70 just like 3 days ago. Look at this. Like, bro, talk about consistency, bro. This is the most consistent I've ever been with Leetcode. I wish I started May 1st, but nope, started May 9th. And it was random. Like one day I was just like, you know what? I'm gonna just start doing Leetcode. I did it, and I think I did a few here. And then I think I decided to stream like around like the next week. 236 submissions. And it's like, bro, I've done 84 problems. That's really like nothing, bro. I don't think you start to get good at Leetcode until you get around 200. Why'd you do 200? I think I'll be at a way better place. I'm honestly not trying to, like, right now, I'm just working on developing my understanding of all these different like patterns and data structures. I'm going to focus on trying to solve problems I haven't seen before once I get through like the Leetcode 150. Once I get through all of this, that's when I'll really start working on getting better at just solving problems I haven't seen, you know. So I'm just taking it one step at a time. I'm not really holding myself to, you know, I'm not being strict with looking at solutions. If I try like 10 minutes and I don't know how to do the problem, I can't even think of like a way to solve it. I just look at the solution. And normally when I look at the solution, I'll look at the solution and I'll think, okay, how would I implement this? And then like, I'll look at how they actually implement it. Okay, what am I doing? Merge triplets to form target triplet. Greedy problems are definitely the hardest that I've done. Not in terms of like once you see the solution, it's not hard to understand, but like just thinking about how I would intuitively go about like solving it for the first time, they're very hard because I can't even really tell that they're greedy. A triplet is an array of 3 integers. You are given a 2-day array. Triplets, where triplets of I equals 8. To obtain target, you may apply the following operation on triplets any number of times, possibly 0. Choose two indices, 0 index, I and j. I does not equal j. And update triplets, j, to become like what? Example, if triplets of I equals 2, 5, 3. Oh, okay. So the j equals 1, 5, 7. Triplets j will be updated to as a 2, 1, 5, 7, 3, and 5. Okay. Target triplet. Update the last triplet to be max to 1, 7. Equals bro, what the heck? Perform the following operations. Choose the first and third triplets. Okay. Update the third triplet to be max 2, 1, 2, 1, 5, 2, 3, 5. Okay. Choose the third and fourth triplets. Oh my gosh. So you have to keep, like, you can keep doing that operation. Can you do that operation more than once? Like, is there a limit? I don't think it. Damn. How would I go about this? How would I even brute force this? Like, if I was gonna brute force a solution, I would basically, like, I would have to iterate through and then try every combination, right? And then update the list. I just remembered that I have somewhere I have to go. At what, 7 p.m.? Bro, if I would I be crazy if I just didn't show up? I'm supposed to bring stuff too. I have to like bring food or something to this person's house. Celtics are on at 8-2. I'd be so sick, bro. Like, I don't have to go, but it's one of those situations where if I don't, I'm just gonna look bad. Anyway, yeah. So if I was gonna brute force this, I would basically take the first index. I would iterate through like 0 through 3, right? I'd have one loop that'd be like for I in range 1, like 3, right? So it'd go from like 0, 1, 2. And that would basically loop through every index, like the 3 indexes of each array. And then I'd update them, and I'd just keep doing that until we have I'd basically continue that operation of updating the different lists in our list until there was a match. I don't know. And so like eventually we'll have. Are we guaranteed a solution? Like if the length of this list is greater than or equal to 3, are we guaranteed a solution? I don't think we are. What was the hint? Is this a heap question? Is it a heap question? What property of max do we actually care about? Yeah, I'm gonna look at the solution. I don't know. Merge triplets to form target triplet. My computer is on fire. This is only a 6-minute, bro. Is this an easy ass solution? Because the video is only 6 minutes. Am I done? Like the way I'm thinking about it might be like it's probably going to be like n cubed or something for the runtime. I don't know if we can use a dictionary in some way to keep track of like I think we might have to just use a set. continuously check if like the results of doing the max operation, like the resulting list, is in that set. Wait, what? So in enumerate T, which T? Okay. Good dot add. Because if there is, so basically the second part we're going through is saying if that okay, that's the part I was confused about. So he's basically saying that like okay, because they have to be different. It's a set. Okay, that makes sense. So you're going through like the first one, checking to see if any of the values in the first list are equal to the values in target, and then you're going through like that second or that last list because the second one wasn't valid. So you're going through the last list, seeing if any of the values in that list is equal to the target list. And you just got to make sure that there's 3 distinct values. And okay, I see. That makes sense. That makes sense. That makes sense. So let me try and implement it. I don't even remember what you wrote, but let's see. We are going to, how long have I been streaming, by the way? Let me check. 2 hours. 2 hours and 5 minutes. Bro, I feel like my eyes, like one of my eyes is like lazy, bro. And why does my shirt look like this? Okay. I know, bro. It's like, I feel like my face is so not symmetrical. Anyway, let me get back to what I'm doing. So we're going to iterate for list, for triplets, and for, let's do for trip and triplets. Right, you want to go through. We want to make sure that none of the indexes, if trip greater than or trip 1, then target 1, or trip 2 greater than target 2. You want to just go to the next one. Then if what do you want to do next? All right, let's go to that. So now we just want, because we need to have a set now. Lookup equals set. And we want to have a set, and we basically want to check and see if any of these, if trip, well, yeah, we want to go through for val and trip. For I and trip, if trip I equals target I. Well, actually, hold up. Can I not do if trip I in set target? Look up. I don't think it matters if you add the index or the target. Actually, maybe it does. I guess we'll see. Equal 3. Oh, whoops. Eh. What did I even do? Does it have to be? Oh, whoops. Okay. Something I did. I just forgot to put 0. Wait, what? Okay. This trip I. Triple I inset oh, in this case, I already added it. I see. So yeah. That problem wasn't that bad at all. Merge triplets to form target. What? Form target triplet. It's probably gonna be the last problem I do. We're given a string. We want to partition the string into as many parts as possible so that each letter appears in at most one part. It's not like the note that the partition is done so that wait, what? So each letter appears in at most one part. So A, each letter appears in at most one part. So A, okay. Oh, okay. I see. Are you guaranteed a solution? Lowercase. Let's see. Let's see. Each letter. I feel like this is a question I've seen before, or it's very similar to another question. Is it not essentially just like maximum subarray? Bugging. I don't know, man. My brain's kind of fried too. I've done a good amount of problems. Splits S into less parts. Do we have to do a count? I feel like we have to use a counter, right? Okay, this is the solution that came up in my head. Quick math, right? So the partition is whatever. This is the partition so that each letter appears in at most one part. So I think what you have to do is you have to use a counter to count the number of letters and as many parts as possible so that each letter appears at most one part. So you want to use a counter, get the number of distinct like characters, and then you're going to sort it, or you're going to take the max, right? I think you might need a heap because you're going to need to essentially, this can kind of be like which question? Task scheduler, right? Because essentially what we're doing is we're going to be taking this, right? And then we're going to need to see the number of distinct elements, put it in a counter, sort it by like the most, and then we're going to need to start by like putting it by the most is, what am I even talking about? And what's that? So this can only appear in each part. So we need to know the number of distinct characters, right? Like of unique characters. Once we know that, I think we might need to know like the number of characters also like the number of each character. And then once we know that, I don't know. Let me check. I'm gonna need to start improving my thumbnails. I just subscribed to these people. Let me see. Bro, they were pretty good. Like, I like their content a lot. And they're doing essentially the same thing I'm doing. I think it started with a W. TVW. Oh, okay. Yeah. Shout out to these two guys. I like the content they make. I was actually in their stream like yesterday. And they just basically go through, solve Leetcode problems. And I think they're both beginners. So kind of in the same boat. But yeah, I like how their thumbnails are. Whoever does the thumbnails, bro, shout out to you, man. This is very good. Like, I seen the thumbnail and I was like, damn, I gotta watch this video. So I don't know. I don't think, like, I still want to have my own type of thumbnails, but I think what I'm gonna do is I might I still want my channel just to be kind of like anime themed. You can see like I have Vegeta crying. So I might try and do like stick figures or something, just quick. Or maybe cook something up in Photoshop. I don't know. Just to get it just to make it look interesting. You can see like, I think once they started adding sort of things, I don't know. I got some work to do. Or maybe this question is kind of like the breadth first search solution. Oh my God, bro. I don't think this problem is hard to understand. I just think I don't know how to do it. I understand what I have to do. I just don't know how to do it. Here's the thing, like, sometimes I feel bad or I feel disappointed in myself for looking at the solutions as fast as I do, right? But in my opinion, like, I feel like the best way to come up with a solution, like, no matter who you are, when you're looking at a problem for the first time, you're going to try and think about problems you've done in the past and think, yo, is this problem similar to anything that I've done in the past? I feel like, especially for greedy problems, none of the problems are similar to any of the other ones that I did. Like, I feel like all these problems are pretty different, or these aren't greedy, but I feel like all of these problems are pretty different. Maybe like even my solution to jump game two is different than my solution to jump game like one. Um, like the solution to this one and jump game two is pretty similar, so I'll give you that. Um, gas station or no, the solution to maximum subarray and gas station are kind of similar. I didn't even understand what gas station was asking the first time I looked at it though. Um, yeah, so I don't know. Well, we can't manipulate. Why did I think that we were allowed to like manipulate the string? Like we could move characters. Okay, I think I get the idea. When did I start doing greedy problems? I'm actually just curious. I started doing greedy 17. Yeah, I mean, I've been doing greedy problems since for like the past 3 days. This is the fourth day. Took me like 4 days to go through 1, 2, 3, 4, 5, 6, 7, 8. Last index. Okay. For I C enumerate. If I. Oh, okay. Yeah, makes sense. That makes sense. That makes sense. That wasn't that bad. I'm gonna do this problem in a second. I am. Okay. So we want to create a dictionary, right? And we want to iterate through just do character. And then we want to, what do we want to do? Enumerate S. You want to, what do you want to do? What are we trying to do? So we're trying to look, we're trying to see, we can set end equals, well, or actually, I don't think we want that. I'll check to see if C, if lookup of C equals, if lookup of C, if I is okay. If lookup of C, right, if that value is greater than the index in I, then we want to set end to equal I, right? If lookup of C equal to I, then that means that we want to, we're also going to need a res. Res.append. Oh, we also need side. We need to keep the count 0. Size. Size. And equals what? 0. Size equals 0. Yeah, all we want to do, hold up. is greater than and and okay. And go last index. N is going to equal the, okay, yeah. Whoops. So speed and equal to I. Do we not have to update end? Well, I guess the indexes will always be greater since we're iterating towards like the right, like from left to right. Okay, that makes sense. What the heck? What am I doing wrong? Where's that append? Oh, am I appending it? Bro, I'm stupid. Makes sense. Okay. That makes sense. That makes sense. Partition labels. Partition. There we go. I am going to like these. That's ones I should do again. Okay, really? Yeah, I mean, what? 86. Did I not just submit that problem? Okay. Did I only have 85? I thought I had 86. I mean, 80. I have no badges. How do I get badges? I have 18 submissions on May. Bro, what? Nice. How do I have 18 submissions? There's 3,156 problems on Leetcode. How long would it take me to finish all of those? I would guess probably like, could I do 1,000 a year? I don't think I could do 1,000 Leetcode problems a year. I think in a year I could probably do like 500. Cause I've been doing this for a minute. I've only done, I think it takes probably like 6 months to do the Leetcode 150. But I think once you've done the Leetcode 150, you could like do problems. Like you can understand problems way faster because you don't have to go through the process of like learning different data structures. But I think I'm going to end. Ant crawling on my leg. I think I'm going to end it there. Thank you. I'll be on probably tomorrow for a little bit. Hey, thank you for whoever Crytux is. Thank you for joining. Thank you for commenting. I really appreciate it, man. It's hard out here, man. It's hard out here, but those type of comments keep me going. I appreciate it.